I got a very interesting comment of one of my followers. He made one of my circuits that I published on YouTube with the BF245, and the BF245 is a N-FET. It's obsolete. It's no longer made in Europe, and it is still made in China. I never ordered that N-FET, that BF245A in China, by the way, so I don't have any experience about how good it is. I only used in the past, in all my videos on YouTube, the Philips BF245A. It's an N-FET. It works very nice. There are three types, A, B and C, and the C type is less sensitive for static charges on its gate anyway. By the way, there are all kinds of field effect transistors, MOSFETs, etc. And when we are talking about small signal FETs, there are enhancement FETs, depletion FETs, of course P-types and N-types, etc. And say the whole idea of field effect transistors is in a certain way a kind of science. Anyway, whatever that may be, I made in the past this field effect transistor tester that can also test MOSFETs. I published it, say, quite a long time ago, but regarding this question, perhaps it's a good idea to show it again. You can test N-type FETs and P-type FETs. The idea is that when the field effect transistor is active, it amplifies. It must work in an oscillator schematic, and this is an oscillator. So no passive testing, but active testing whether such a field effect transistor can work. The oscillator is very simple. I will give the link in the description to the earlier schematic. And well, you can test, like I told, N-types and P-types. You can also test MOSFETs. And I also found that in certain cases, not always, this field effect transistor tester also worked for silicon transistors. So you could also get here a silicon transistor into oscillation. Anyway, that was in a certain way a kind of extra. The whole idea was to make a circuit to test FETs and MOSFETs. And the idea is, like I told, when it oscillates, it's okay. So, that's more or less all to tell. This will be a very short video. The schematic is already in an earlier video. Here you connect the drain, here you connect the gate, and here the source. The drain, of course, always to the positive when it is an N-FET, but here we can switch, reverse here the voltage, that it can work for N-FETs and P-FETs, and also for N-transistors and P-transistors. PNP here, green LED, and PN transistors here. Anyway, so what's more to tell? There is, when it works, there is an oscillation. You can see it here. I don't know the exact frequency. You can, of course, surely test that with a frequency counter. I didn't do that now, but important to tell that this is only one of the oscillations that the circuit can bring. It can also bring, say, this type of an oscillation. So a peak here, and then ringing out, here a peak, ringing out. That also means that the field effect transistor or the MOSFET is okay. It shows that it works. Anyway, that was all. Thanks for watching. There's much more in the earlier video on my YouTube channel. The schematic again. Of course you need an oscilloscope. Well, the oscilloscope. Without an oscilloscope you are in a certain way completely in the dark. When you want to make electronic circuits, be it audio amplifiers, radios, oscillators or whatever, you absolutely need an oscilloscope. Otherwise, say, serious testing, etc. is not possible. And the oscillator is made in a very easy way, with a few steel nails, etc.